Now that we have an overall idea of the modus operandi of larval Myrmeleontidae, the worldwide family of antlions, we want to examine some of the amazing biology and analyze the physics of each specific task. We will necessarily ask, what environmental variables can affect the successful outcome of each accomplishment for our bold critter? And what might intervene to deny effective ant catching? Essentially, what makes a cone of sand slippery to an ant, especially large ants, the biggest catches? And what might make escape easier besides intelligence, which God has denied the ants? The first mystery is simply this: how does anything dig a small pit, which when finished will have a uniform slope of fine sand, free of obstructions, and ready to slide downward at the slightest twitch of an ant's leg? More specifically, on conclusion, the animal must also find itself at the very bottom of this pit, the bottom of this dirt maelstrom. Engineers might propose some kind of tiny scoop, which was kept lifting material from the very center of a circle until the sliding cone was completed. But evolution has arrived at a much better method. As you may well see, our hero has already begun by backing counterclockwise in a spiral of about 2 inches circumference. It jerks backward, and each time its head gets covered with sand particles, it flips a load out of the pit. How could anything so jerky ever build to such a delicate set of specifications? Notice that the larger sand pieces are especially grasped by those multi-purpose forceps, and thus hurled the furthest. This may be a critical point. What is left to slide back into the pit, finally, are only the finer particles, the very ones which will make a silky smooth sliding surface for his next victim. Getting rid of large sand particles, twigs and pebbles might well be a success breaker factor, because large ants getting one leg on a firm footing might leap to the surface and be gone. You may well have noticed that our hero is also having a less than hoped for run at it, because here he has run into a bowl edge, perhaps not a likely factor out in the real world, and many of his pitches of coarse sand have come rolling back to be dealt with again. So we may have unwittingly provided this antlion with two extremes in the environmental variables department. We gave him near pebble-sized sand particles, which his mother's laying instinct might well have instinctively avoided by laying her eggs in sand of better texture. And we have put him in a small bowl, which his mother would almost certainly have eschewed. The sand in this bowl also is not very dry, so it mounds up over the antlion's back. Thus you will notice that he responds to this and the bowl edge by reversing direction toward the end to clockwise as the spiral gets smaller, and attempts to more clearly throw the heavy sand pieces away from the bowl edge where they do not roll back as often. As the pit gets deeper, the spiral gets smaller, until, just as the specification read, the critter comes to lie in the very center of the sand slide. Lastly, it also positions its fang mandibles at the widespread trap set position, leaving only its eyes blackly gleaming upward. It may be in for a wait of several days or weeks, no problem. Real predators have evolved to prepare for patience.